And welcome everybody to our daily space weather video 3 of 3. This is our bonus feature segment. We're starting things out looking at the total electron content forecast. That's the coupled thermosphere, ionosphere, plasmasphere electrodynamics. Coupled thermosphere, ionosphere, plasmasphere electrodynamics model. So we're seeing kind of low levels here of electron flux, as we typically do see during a coronal hole wind stream. Also, very narrow bands here over portions of the planet, like over Central Africa, the Indian Ocean. You can see these high levels of GPS errors kind of thinning out there. Keep in mind, September is the most geomagnetically active month of the year, followed by March. So around the equinoxes is the time when we expect the most geo-effective behavior from the sun. So that's your total electron content forecast. It's showing you the electrons in the plasmasphere, the other plasmasphere, the inner Van Allen belt, and indeed the upper atmosphere, as your GPS satellite must communicate through a lot of electrons, especially around the equator at noon, causing errors. So we do see some minor charging hazards here over the Central Pacific as well. Those kind of charging hazards are caused by the lower energy relativistic electrons. Here's the 1-year chart of the greater than 2 mega electron volt, the relativistic electrons. That's the 1-year chart from Solon.info. Here's a 3-day graph. The measurements from the GO 16 and 17. They use radiography to measure the electron flux at the F ionosphere layer from their geosynchronous near equatorial orbit. Low levels of electron flux associated with coronal hole wind streams. It's typical, and we're expecting to see a precipitous uptick here after the coronal hole wind stream subsides. The green boxes are the forecast. The yellow diamonds are the observation. Next, we're going to show you the ionosphere. This F layer is located at about 300 kilometers of altitude. Here's the vibrational frequency of the ionosphere. So that's megahertz, millions of vibrations per second. There's a lot of vibration going on above your head. And here's an ionogram of it. Next, the Anomaly Gram. This is the anomaly in megahertz from the 30-day median. Quite a few low-frequency anomalies here over places like the southern Atlantic Ocean, southern South America, and the South Pacific. High-frequency anomalies north of the 30-degree latitude line there. Anyway, here's the latest image. That's the ionogram, 12 o'clock Universal Time. There's the Anomaly Gram for that same time, 12 o'clock Universal Time. It's 12 noon in Greenwich Mean Time. Next, I'd like to thank everybody for tuning into the video. Welcome to the Neo Renaissance. Congratulations on realizing the channel exists. Please visit our links. Support the channel by becoming a member of the Smash team. You can find links below the video and at smashamash.com. Also, links to our merch you'll find there. We've put up all of our merch for sale through the month of February. We'll be paring down this list, so if there's something you haven't seen before, scoop it up during the month of February, as it might vanish once we reach March. Those are in order of best-selling. Thanks to everybody who's picked up merch and helped to make Earth not suck again. We're doing our part. And smashamash.com/Smash Team is part of it. Gold and Silver Smash Team members receive daily disaster reports. Were you aware? smashamash.com/Smash Team. We've replaced Patreon with a superior subscription services site. Let's move on to ground-based solar observatories. And today we're looking at the data from Udaipur, India. The National Sunspot Observatory ground-based system at Udaipur, India, showing hydrogen alpha, 6,562.8 angstroms is the wavelength. And we've got a little reduction in filaments here. There are still quite a few filaments on the Earth side of the solar disk. You can see one here showing up as a prominence. These showing up as absorption features. And don't be surprised to see coronal mass ejections. We'll cover it if it happens. Next, the latest magnetogram and intensitygram. So we've got some minor pores here in the southern hemisphere. They're all quite insignificant. Tiny little sunspot groups down there. One slightly larger group up here. So we're going to have 5 named sunspot groups today, and here's the most important part. Sunspot 2954 and 2955 will be the name of that. Great penumbral lines there around those. They're both well-defined. They're both larger than planet Earth. Here are the fields. And again, those are both North Pole-oriented sunspots, so they're both alpha-class separate groups and not exhibiting a lot of magnetic complexity. Next, we'll show some latest imagery here from the GOES 16 SUVI. It's great wide field of view. Fantastic at showing prominences. So when we do see coronal mass ejections, this is a great satellite through which to view them. The GOES 16 in its geosynchronous near equatorial orbit. Things pretty calm at the moment. Here's the last 24 hours from the SDO, a little higher resolution here, and a little narrower field of view from the Solar Dynamics Observatory. We've got some additional views here. We're going to show you some close-ups of sunspot 2954 and sunspot 2955. Here ends today's Daily Space Weather Video bonus feature segment, part 3 of 3 of our Daily Space Weather videos. We'll close out with the full disk view in 94 angstroms. Keep staring at the sun, folks. Congratulations on realizing the channel exists, and may that solar wind be at your back.